let's first think about the base case. So when n is smaller than 10, this might be the base case. All right. Then what we're going to do is return just n. Because when we want to sum digits, a single number, and it's going to be just 8, right? And in other cases, if n is larger than or equal to 10, then what we are going to do is return n %10 plus some digits and /10. However, when you actually, you don't have to put else here, because when you call return here, then this function will end here. It will not go below this part, right? So you can just skip writing else. So you can save some indentation like this. So this one is from some of our students, one of our students. When you implement this function in this way, then it might be somewhat confusing at first. So what I suggest you is give some names to these values, right? So what I'm going to call this one is the last one, all right? So we are going to save the last one. And I'm going to call this one as all but last, all right? So we are going to pass this all but last to our sum digits function, and it will work correctly. We just assume that it will handle the rest of it. We just think about the base case, all right? So this is how we implement this sum digits function. And when we call sum digits, it's going to be 7 like this, all right? So any questions about this implementation? All right, let's move on. So one question is, why can we remove the else statement or else keyword? Let's talk about here. I told you that sum of any one-digit non-negative number is just that number. So that is our base case right here. And the sum of a number is the sum of the first digits, the first k-1 digits plus the last digit. So that's what comes here. And the difference between these two implementations is just removing this else keyword. Because when a function meets or reaches return statement, it will not go below this part, right? So in the view of this sum digits function, it has only this block or this block. So even though we remove this else statement, because we have return here, it works as separating these two blocks, right? So that's why we can remove else keyword, because return finishes or terminates this function. So these two blocks are separated by this return keyword, all right? Let's move on. So that was about just normal recursive functions. And from now on, I'm going to talk about mutual recursion. So what is mutual recursion? The definition of mutual recursion is a recursive procedure or function is divided among two functions that call each other. So in our previous definition of recursive function, a function called itself. However, in the case of mutual recursion, these two functions will call each other like this. And I'm going to give you one example. A number, this number here is an integer, is even if it is one more than an odd number, right? So numbers alternates between even number and odd numbers. 1, 2, 3, 4, 5. So this one is odd, even, odd, even, odd. So they alternate, right? And a number is odd if it is one more than an even number, right? Because they are next to each other. And 0, let's say it is even. All right. And how can you define some functions that checks whether given numbers are even or not? Let's implement this function together. What we can do is, when we're given a number, if n equals 0, so this is going to be our base case. When n is 0, then we define that 0 is even. So we are going to return true. Otherwise, what we are going to do is return is odd. So we are going to check if this number is odd or not. When I finish implementing this function, this might be clearer. If n equals 0, that means this number is not odd, right? And what we're going to do is even and -1. All right. So this is, so is even calls is odd, and is odd calls is even. So when we run some functions, some examples, it will return false and true like this. All right. So rather than tackling these big number, we just split or decrement this number into smaller ones and reach the base case. All right. So this is what a mutual recursion is. And I'm going to give you another example of mutual recursion. This one was quite simple, and in practice, we don't implement is even or is odd functions this way. We just use percent operation. That is much intuitive, right? So I'm going to talk about the LON algorithm. This LON algorithm is used to verify if a credit card number is valid or not. So how do we do this? So from the rightmost digit, which is the check digit, we move towards the left. And we double the value of every second digit. And if the product of this doubling operation is greater than 9, then sum the digits of that product. So when you see this definition, it might be somewhat confusing. So let's say we have 1, 3, 4, 7, 2, 9. So what we are going to do is we start from the rightmost digit. And we call this one as check digit. And we move towards the left side. And when we reach the even position number, we're going to double this one. So this will become 4. And when we reach or encounter even position number, we just pass. And when we encounter this number, we double this one. So what if this number was 9? And when we reach this number, we're going to double this number it's going to be 18. And this is larger than 9, greater than 9. Then what we do is just sum these two numbers, and it's going to be 9. All right? So this is the first step of the learn algorithm. And what we are going to do is sum these numbers, 9, 3, 8, 7, 4, and 9. All right? So for example, if you have this 1, 3, 8, 7, 4, 3, all right, can you guys calculate the result of run algorithm when we input this number 138743? All right, thank you for sharing your answers. So let's calculate this one together. So for the first digit, what we're going to do is just let it remain 3, right? And when we encounter 4, because it's on the even position, we're going to double it, right? And 7, it remains 7. 8, it's going to be 16. However, it's larger than 9, so we are going to sum these digits. So it's going to be 7. And 3 remains 3, 1 becomes 2. And then we sum these numbers, that's going to be 30. So everyone is getting the right answer, I guess. And if the lump sum of a valid credit card number, so if this number is a multiple of 10, then that means this credit card number is valid, all right? And my question is, can you implement the learn algorithm? You need to use mutual recursion, as well as the sum digits we used before. You can modify the sum digits in some way. Then you can implement this learn algorithm. Try to think about how you can implement this learn algorithm. I'll give you like 3 minutes.